Okay, let's make some guesses here about the direction of these currents. Let's guess quite reasonably that this current flows that way, right? This current here flows this way. And that those two currents flow back to the back sides of these cells this way. And I'll call this I1. I'll call that I2. I'll call this I3. Okay, now in this case, if we look at this junction right there, okay, and we figure out the currents flowing in, they have to equal the currents flowing out, right? So I believe that I2 plus I3 equals I1, okay? And if we make this into a matrixable form, it looks like, let's do that. Matrixable form looks like this. Negative I1 plus I2 plus I3 equals 0. You always want 1, 2, and 3 that way, right? Okay, so we're done with the junction rule, okay? And then let's go, I'm going to go clockwise around this loop here on the left side. That'll be my first loop here. I'm going to start here. Okay, so I'm going upstream through 7, upstream through 8, right? So I'm going to go plus 7I1 plus 8I1, okay, because I'm going upstream, right? Okay, then I'm going to go plus 3I2. Then I'm going the wrong way through this battery, right? So minus 45. Okay, and then I'm going to go up 4I2, right? And now I'm back, right? So let's just double check. So I'm going up 7, up 8, up 3, down 45, up 4I2, right? Okay. So let's make this thing matrixable. Okay, if I matrixable this thing, what is that going to look like? Let's see. I think we are plus 15 plus 15I1. Okay, and then I2, how much I2 do we have? We have 7, so plus 7I2. Okay, plus 0I3. Okay, equals 45. Okay, so there is in matrixable form. When I say matrixable, I just mean that we've got the I1, the I2, the I3. We've combined all the terms. We've put all the constants on the other side there. Okay. So now let's do a clockwise traverse of this circuit. I'll start here and I'll go clockwise there. Just creature of habit here. You always stay the same. Okay, so let's see. Now we're going downstream, right? So we're going to go minus 4I2. Now we go the right way through the battery, so plus 45. Okay, minus 3I2. Okay, now we're going upstream through these guys, right? So plus 2I3 plus 6I3. Okay, plus 9I3. You could, by the way, just add these resistors together. There's nothing magical about doing them separately. Okay, now we're going the wrong way through the 15 volts. So we're going to go down 15. And I think we're at 0 again. So let's just double check. Okay, so downstream, so minus 4I2 plus 45 minus 3I2. Now we're going upstream, so it's pluses, right? Plus 2I3 plus 6I3 plus 9I3. Then we go the wrong way through this guy, right? So minus 15 is 0. Okay, so now let's make that matrixable. If I make this matrixable, I have 0 I1s minus 7 I2. Okay, and then I've got plus, how much do we got? We got 2 and 6 is 8, that's 17, right? Okay, so I've got plus 17 I3, and then what goes on this side? Negative 45 and positive 15, so that's negative 30, right? Did I get the sign right? Yeah, I sort of have this nagging feeling, right? So this is our properly matrixed thing here, right? Okay, we got this, we got this guy's also in matrix form, right? We got I1, I2, I3. Okay, so now let's do our matrix here. Okay, so we are going to do this matrix here. Negative 1, 1, 1 to the minus 1 times this. That's our constant one, right? And then that's going to equal I1, I2, and I3. Here we go. That's an I. Okay, so 1, negative 1, 1, 1, and then on the right side is 0. Okay, so this guy's going to be 15 and 7 and 0. And then on this side we got a 45. Okay, this guy's going to be 0, negative 7, 17, and then this is negative 30. All right. Are we ready for this? Let's try this. Now, we may lose everything here, but let's just give it a try. Okay, here's our calculator. Let's turn it on. Let's clear everything. And then I'm going to go alpha F3, and I want to choose 3 rows and 3 columns. So I hit enter, then go down and hit enter. And now I can just start typing in negative 1, 1, 1. All right, let's just pause a moment and be thankful for the mathematicians who figured this out. Okay, 15, 7. The nice thing is if you go left to right as you fill in the rows, it works better because like when I hit right, it takes me right to that thing. Okay, that's a 0, and then this guy is negative 7 and 17. And then I'm going to go right arrow. And what I want to do is invert this thing, right? That's the inversion thing there. Okay, so I use the x to the minus 1. Okay, and now I need to stick another matrix in here. Okay, so alpha F3. This guy is going to have 3 rows, but only 1 column. So let's go down here, hit enter, go down, click OK. And in the top, we've got 0 is correct, 45, and negative 30. Okay, now prepare yourself for the shock of what's about to happen. Holy cow, if you look at that last one, the current on the right side, it turns out that a 45-volt battery is enough to push current the wrong way through that cell. So we guessed that that was pushing current up, but it's actually pushing current down. Okay. Ooh. All right, so what I'm going to do is I'm going to grab these values out. Let me show you how to do that. Okay, I'm going to go storage, and then I'm going to go second matrix, and I'm just going to grab matrix A. I'm going to store those values in matrix A. There it is. Okay, and then you can actually address these matrices. So I'm going to go second matrix, and I'm just going to do the names. I'm going to barf out A, and then put a parenthesis. 1, 1. So that is row 1, column 1. There is only 1 column, so if you ever put like a 2 in that second thing, you'll get a dimension error. Be like programming, you know. I'm going to store this guy in alpha A. There it is, right? And then I'm going to store the next one in alpha B. So this is the second row, first column. Store that in B. And then I feel like what I want to do is I want to make these numbers positive. I don't want to deal with negative numbers because that'll just warp my mind more than it already is. Okay, I said it before you said it. Okay, so I'm going to do this and then grab this guy. So notice I put the opposite there because I don't want a negative number to deal with. So 3 and alpha c. There we go. So I made that number positive. Okay. But now we need to go back. Let's go back to our picture here. Okay. Okay. Notice how we said that it was this way. Well, that's not true. Okay. So it's actually going this way. We guessed up, but because our number came out negative, the current's actually getting forced backwards through this thing. Okay, so this is what I do, because I have to know which way that thing actually went. Okay, so the currents are down, up, down. Actually, they are down, up, down. Okay, and I am storing this guy in A. My variable A, I'm storing this guy in B, I stored this guy in C. That's what you saw me do. Okay, so this is 1.816 down. This next guy is 2.537. I'm rounding. Right, it's all of it's there, going up, right? And then this guy is 0.7203 roughly. And I'm just carrying a bunch of sig figs. In actuality, I'm going to use these variables to calculate the currents. Okay, so let's take a look at the voltage across the 8 ohm. Where's the 8 ohm? There it is. Well, that's going to be just IR, right? So it's going to be I1 times 8. Okay, times 8. Okay, so the formula I'm using is V is IR, right? Okay, so that is going to be 1.816 times 8. Okay, now notice that I stored that in A, so all I have to do is this. 8 alpha A, boom, 14.53. Okay, let's find the voltage across 2. Where's 2? Oh, 2 is there. So 2 is going to be V is IR, right? So that's going to be I3 times 2. So that's going to be I3 is this guy. So 0.7203 times 2, okay? Which is just 2C, right? 1.44. Okay, so let's figure out the power. Okay, the power dissipated by the 3. Well, I'm going to use power as I squared R. Where's my 3? There it is. It's right there. Okay, so that's I2. So that's going to be I2 squared times 3. So that is, what's I2? I2 is 2.537. Squared times 3. Okay. Now literally, that's, I stored that in, it's going to be 3b squared. Okay. 3 alpha b squared. 19.3 watts. Okay, this guy is going to be, this power is I squared R. So that is, let's see, 9 is, where's the 9? There it is. So that's I3, right? So that's going to be I3 squared times 9. Well, I stored that in C. This guy's stored in C, right? These are my variables that I've stored this in, right? So let's go there, and it's 9 alpha C squared. That's 4.67 watts. Okay, now finally we get to the dreaded V1. Okay, the dreaded V1. Now, to do this, I'm going to go for this. I'm actually going to go. I'm going to put my life on the limb here. I'm going to actually go from the left side to the right side. So I'm going to go left to right. And there's two ways I can do that. I can go the lower route, or I can go the upper route. Now the upper route's easier. It only has two terms in it, but let's do both. Let's do the lower route. So I'm going to go from this side to this side. Okay. Notice I'm going downstream through this 7. So it's going to be minus 7I1. Minus 7I1. And then it's also going to be downstream through the 4, right? So minus 4I2. But then we go through the back of the cell, right? So then we go up 45, right? Okay, so again, downstream through 7I1, downstream through 4I2, then up 45. So let's see what that is. Okay. 7, 4, and 45. Okay, so negative 7A minus 4B plus 45. This is 22.13 whatever. Okay, I'll say just say 14. 22.14. Now notice that in going from left to right, we became more positive, okay? So this side is the positive side. This side would be the negative side of your voltmeter. This side is more positive. Now let's see if it's true. Let's do the upper route. Okay, so we're going to go this way. We're going to go to left to right. I'm going to go up 8I1, okay? Up 8I1. Is that right? Yeah, because I'm going upstream through that, right? So plus 8I1. Okay, now I'm going to go up 3I2. And that's it. I'm there. Okay, so 8I1, which is this, okay, plus 3I2. Let's see if that also equals 22.14. I hope it does. 8 and 3, we can remember that. Okay. 8A plus 3B. It's like crazy. Now, by the way, if at this point in your solving of this, you get two different numbers from that, you made a mistake. There's something wrong. It all should work. So I'm going to say that that's 22.1 volts, because it is. Okay. I think we solved it.